Oh, no, it's fine. My name's Rew. I started as an iOS developer at Dashlane. I realized I wasn't very good, so I let other people do that. And now I do other things. For the last 3 years, I've been working on passwordless technologies, primarily focused on passkeys and everything that revolves around the FIDO Alliance. I'm a co-chair of the FIDO Credential Provider Special Interest Group. It's a very long name. Basically, it's all companies that do credential management. So Apple, Google, Microsoft, 1Password, Dashlane, Bitwarden, and others. We get together every 2 weeks and we talk about the problems we have and we think about solutions. I'm also the board representative of Dashlane to the FIDO Alliance. And you might be wondering, what the hell is the FIDO Alliance? So I'll just quickly give you an overview. If you use USB or Bluetooth, I imagine everyone does, that stuff usually gets developed in a standards body. It's usually a bunch of tech companies that get together and think about how to create a standard that's interoperable and that everyone can use. So this is a standards body that wants to get rid of the password. And these are the companies that are involved. As you can see, the 3 major tech companies, Microsoft, Google, and Apple, are involved. Apple joined actually, was the last to join, I would say. They joined in 2020, and passkeys came a thing in 2022. It was founded by, I think, Google, PayPal, Intel. I can't really remember, to be honest. But today, these are the board members. There's a whole list of other companies that are involved in the FIDO Alliance, but these are the ones that represent the FIDO board. So you see like the big mixture of companies. You have some password managers like 1Password, Dashlane, LastPass. You have some financial organizations like Visa, Wells Fargo. And then you have technology companies like Knock Knock Labs, IDEMIA. If you've ever gone through passport control in the US, you probably went through an IDEMIA machine, et cetera, and Meta and whatnot, and TikTok. So that's the FIDO Alliance, and their goal is very simple: to reduce the world's reliance on passwords. Why do they want to do that? Passwords suck. We're a password manager, and password managers are a thing because passwords really suck. And they suck for 3 reasons, and that relates to the FIDO Alliance. The first reason is most people have bad passwords. If they're not using a password manager, if you ask your parents or your cousins, do you have 1Password that you use in all your websites? They'll say, yes, I do. And is it a really good one? Yeah, I have a great password, but it's not. So that's the first flaw. So it's guessable. Someone can guess your account. Once they've taken over your account, they can extract it for money or hassle you or whatever. Second problem is phishing. Like, this is the biggest problem on the internet today. It's the #1 cyber attack, I would say. You get an email. It's got a link. There's an urgency. Your account's been breached. You need to confirm something. You create a social engineering situation that forces you to think, oh my God, what do I need to do? Click, click. And we're all used to just clicking and smashing green buttons. So we do it, and then the account gets taken over. Third way is a bit more sophisticated. It relies on actual hacking, because all this is just social engineering. Hacking like the server to get some information that's hosted on the server, which in the worst case scenario would be a database of plain text passwords, clearly. Sometimes they're hashed, but even when they're hashed doesn't mean that it's not valuable to the attacker. So these are the 3 kind of problems that FIDO tries to solve. And if you're familiar with cryptography, particularly asymmetric cryptography around the kind that allows you to sign and verify, it's essentially like SSH, if you think about it, or TLS. You store a private key somewhere, and you give the public key to the server. So, well, you're not remembering anything anymore. Some software is handling your credential. The aspect of this technology is that it's bound to an origin. So it won't work if you go to a phishing site. The credential will not activate. And if the server gets breached, the public keys, well, they're public keys. So the way the plumbing works is that you have this relying party, which is the term they use to describe a server that relies on an authenticator to authenticate you. And then you have the relying party's app or service, which can be the website, the mobile app. Then you have the OS browser layer, which is either Safari or Chrome or Firefox or like iOS or Android. And then you get the authenticator, which is what we are. We are the authenticator for people's passkeys. And that's the model that we have. But we also have another way of interacting, which is we are the relying party, and we have a new feature that we're developing where you can actually set up Dashlane with a security key. Security keys are passkey providers in a way. You store passkeys in them. One aspect of them, which I won't go into too much detail, is that there's a particular extension in the WebAuthn specification that allows you to encrypt and decrypt data. So we use that as your master password in a sense. It allows you to provide keys. So we're both the authenticator, but we also use FIDO as a way to protect Dashlane. And the reason I mention this is if you have a service that has a password and maybe an SMS OTP, it's phishable. It's going to be attacked. And we're getting attacked. Our competitors are getting attacked. The big tech companies are getting attacked. They have mechanisms to prevent that, but the best mechanism is obviously YubiKeys. Sure, not everyone is going to buy a YubiKey to protect their accounts, but if you think about it, if you're now putting all your synced passkeys, which are meant to be phishing resistant, in a credential provider, what protects the credential provider? Once you've popped the credential provider, you have all the passkeys. So it's kind of like moot. So I think for those that are conscious about security, should consider using security keys. So just a quick, look back in history. This is the point of the talk I'm going to get to in a minute. Password managers have been around a while. This is for you guys. Apple introduced iCloud keychain password autofill in 2017, and we were like, wow, this is amazing, but there was no API first. We're pretty sad. So, like, great, password autofill here's here, but your favorite password manager cannot use it. And we thought that really sucks. So we didn't have Zoom back then. Well, if it exists, we didn't know about it. We had this thing that you press the buttons and it dials a number, and then you say your name and, you introduce yourselves. So we got on a call with our friends at 1Password and LastPass. We're like, this sucks. Like, we should be able to autofill. Like, we've been autofill stuff for years. We should be there. So we got together. We, filed a few feature requests. And does anyone know anyone at Apple? Like, it's really hard to get to know them and engage with them. I think 1Password had great connections, so they promoted this idea. Apple loved it, and then the year later in iOS 12, maybe. I can't remember. Yeah, iOS 12, sorry. I didn't have a screenshot of iOS 12 because I don't keep a picture of every one of them. Now you can enable Dashlane as your password provider. It's kind of cheating here because it goes on to talk about passkeys. So what I want to talk about is not passkeys itself, but how do you actually move your passkeys? What if you want to stop using Apple and you want to use Dashlane, or you want to stop using Dashlane and use another product? Typically, you'd use a CSV file, which is crap. Sorry, let's step back a bit. In 2022, passkeys became a thing. Apple, Google, and Microsoft supported the FIDO standard. And the internet kind of exploded because, oh my God, big tech, they're locking you into the vendor. Passkeys is just a mechanism for you to be locked into an ecosystem. And we looked at this and thought, well, it's kind of true. I mean, you can't put private keys in a CSV. Well, you can put private keys in a CSV file. It's probably not a good idea. You probably won't get a lot of love from the industry if you do that. So we at Dashlane were thinking, sorry, let me explain a few other things. Just for you to understand, if you do have a security key, it is a kind of like a password manager. It stores passkeys. There is this thing called local device passkeys, and if you've been around a while, if you use Touch ID on your Mac, you would remember that the key would stay on your Mac, but you couldn't use it on other Macs. This was a temporary phase. Chrome still does this, Windows still does this, but the future is what's called synced passkeys, where your ecosystem account synchronizes the private key through the cloud, and these other companies so you don't really need to see that slide. You know what I'm talking about. Neither that one. So as I was saying, these products import and export using CSV files, which are plain text, unsecured files. This is a great example. So basically, you export your stuff. It has all your passwords in it. You upload that to Dropbox. You share that on the internet. It's great. It's plain text. It's not encrypted. The worst thing is there's no formatting. We do it one way, 1Password does it another way, Bitwarden does it a different way. So we all have to learn each other's formats, which sucks. It's a lot of development work, and you can't store passkeys in them, which sucks as well. So the design goal, what is it? We want it to be encrypted. We want a common data format. And as password managers, we're not only serving consumers, we also serve businesses. So what about the business case where a company might want to transfer, like from one product to another? How can that work? So we wanted to make sure that case was also catered for. I'm going to play some fun videos because I think it's fun. So we came up with this idea and we presented it. Well, no, we contacted 1Password and said, do you want to do a presentation at FIDO? And so FIDO meets up every like 3 times a year. We get together in some city and we share like work ideas and progress things. So we presented this. It was actually a hackathon project at Dashlane. Every now and then we have some hackathons and we come up with ideas. So we're like, how can we transfer data from one provider to another in an easy way? There's going to be sound coming out of this. Hopefully it works. There's not going to be sound coming out of this. Give me a second. I think I need to share the sound. Plus. Ah oui, t'as raison. I don't know enough French. Partager. C'est bon. Désactiver isolement de la voix. What does that mean?
It's okay.
Okay. Diaporama. Oh, yeah, it's working.
This is not loud.
Oh, it's working, sorry. Why is it not very loud? Okay, you can't hear the sound, so I'll just... Why is it not working? It's weird. So this is the old way of moving things across. You log in with your master password. You save a file. And then the sound's the best bit, by the way, sorry. Then you export it. And you're really missing the music, sorry. I can hear it. So yeah, the idea was like, what if we like dragged an empty box from one product to another? Like, it's like a public key being dragged over. There's some Diffie-Hellman going on. Then you drag the encrypted data with the other public key and magic. Sorry. Can you make it work? It's so annoying that there's no sound. Anyway, I'll try to put it loud. Cool. So we presented that at FIDO. We didn't know what to expect. It was just us and 1Password. In the audience were Apple, Microsoft, and Google. We expected a bit of, I don't know, criticism or doubts about the idea. They were very eager to make this work. So they loved the idea. And the next step was to develop a standard, which is what we did. Just to explain some of what's going on. When you saw the empty box being dragged over, it was a public key from one product, which had an ephemeral private key. And then on the other side, all the data gets encrypted with the Diffie-Hellman sort of key, and then you drag the public key. So it wasn't just dragging things, there was actual stuff going on in the background. Is it? Oh, sorry, it's on the screen. Okay, if you can get the sound to work, that'd be great. Cool. And Apple and Google took this away and they thought about it and they thought, how's this going to work on mobile? Because you can't drag boxes around on mobile. And the idea was, let's say you're on this is one of the concepts, right? It's not exactly what we're going to do finally, but you're on the importer, you click import, your operating system knows which apps can export. So it presents the exporters, let's say. You select one, you go to that exporter, you sign in, you do your master password. Do you agree with exporting all your stuff? Giving away all your credentials, you click export, it goes back to the importer, and voila. No CSV, no files messing around, a few clicks, and all your data's there. So we were excited, Apple and Google seemed excited, and we weren't sure what would happen next. So yeah, it's encrypted, common data format, accommodates all. So there's 2 standards that we developed. And when I say we developed, like we basically sit in a room, we use GitHub and we make issues, and then we just like define the specification over like a year or so. One of the standards is the format, like how do you describe a password or a passkey in sort of like standardized way. The other one was the protocol, like this cryptographic part. How do you agree on what algorithms to use, etc. So we're using something called hybrid public key encryption, HPKE, which formalizes like the public, the asymmetric and symmetric key encryption. And if you had the sound, you would hear this guy telling you about this fantastic credential. Actually, no, I can't put the. So yeah, so Apple presented this at WWDC. I think one of the sessions called "What's New in Passkeys." Maybe it's at the very end. They talk about how they worked with members of the FIDO Alliance. It's not going to work, don't worry. So here you see an example where partly what I showed you. So this would essentially be Dashlane. You'll be able to just click, select Dashlane, or another password manager when you choose. There's no sound. It's fine. Yeah, it's fine. And that's it. I don't think he says anything much more after that. What does he say? I'll just skip to the. Yeah, there's nothing else. Ugh. That's it. Thanks so much. I kind of went a bit fast. Does anyone have any questions, or do you do questions now? Yes. Shoot. Oh.
This one, merci. And this one's on. Yes, this was in the. Okay, perfect. Here you go. Oh, all right.
Hi, thanks. Yeah, it's super interesting to get an inside look into this thing. So I'm wondering, is that like in macOS, for instance, does Apple have a list of approved password managers that you can transfer passkeys to, or like can anyone build a new one and it'll show up?
As long as you have the entitlement, and then you have it. Yeah. So I guess they would have to accept the entitlement, and the reason why you want that entitlement, like anything like camera access or contactless access. So I think it's just down to the entitlement.
Thanks.
I'm absolutely not a crypto person, so this may be a very dumb question. I don't understand when you say you built a standard. Does that mean, I don't know how much you can disclose this, but does that mean that you essentially implemented some weird custom form of Diffie-Hellman, or is that like a standard? Yeah.
It's a great question, actually. No, so what I mentioned a standard, an RFC called HPKE, Hybrid Public Key Encryption. It's what formalizes the Diffie-Hellman mess. Because there's no, like, Diffie-Hellman is a thing, symmetric encryption is a thing, but there isn't a crypto system that formalizes how you can agree on doing that between
So
two
it's not
parties.
the underlying math.
Oh, no cryptography has been invented here. It's literally using off-the-shelf existing algorithms and libraries. Yeah, and it's it's agnostic. So if there's PQC algorithms in the future, we don't need to use like elliptic curves, blah blah blah. We can use whatever algorithm. What we've standardized is the format. Like, how do you describe a password? How do you describe a passkey? And all the types that are in the vault, so that we all agree like the common format. And then we are agreeing like on the encryption part, because obviously we need to know how we're talking about this to each other.
And I have a second question, which is, I'm sure that there's quite a substantial amount of risk in implementing this sort of thing. So I'm just curious to understand. I know that Dashlane has a sort of bug bounty thing going out, but how did you ensure in a product that hadn't been shipped to production that it didn't have like a huge, massive vulnerability that would allow attackers to gain access to all of people's credentials?
Yeah, so the credential exchange is an API that Apple provides us. Yeah. So we're calling system APIs. So we're kind of like deferring to the system. And it was a discussion within the FIDO group, like, what's the threat model? What are the different forms of attack? And what we agreed on was that the exchange can really only just happen on the user's device between apps the user has. It's not going to be something that, like, it can totally work like over the network. So that, I don't know, I want to exchange my credentials with my cousin in another country. The technology is totally there, but we decided to limit it to same device, native apps, device to device, like app to app on the same device. So that limits the scope a little bit more. And then obviously you need the entitlements. So the App Store kind of controls that a little bit. Then you need the user to authenticate when they are agreeing to export stuff. So they need to know their master password or do their Face ID. So there's different layers of protection, but at the end of the day, you're trying to move credentials from A to B. There's always going to be risk. There's no guarantee that someone doesn't develop a malicious app, puts it on the store, convinces users to install it, and pulls all their credentials. We'll see. But we've put all the effort in to make sure that's like the worst case scenario.
Thank you so much. Great
Thanks.
insights.
Any other questions? Cool. Thank you so much. Yeah.